how does 3D printing actually work? How can you turn a spool of plastic into a real object? It's not that easy. Today, I'll show you step by step. You've probably seen those mesmerizing time lapses of printers building objects layer by layer. But what really happens before and after that? In this episode of 3D Explained, we'll walk you through the 4 main steps of FDM 3D printing. From getting your model to slicing, printing, and finally post-processing. If you're brand new to 3D printing, this video is made for you. And if you're already familiar with FDM or any other additive manufacturing process, you might still learn a thing or two. And maybe want to share this video with a friend, colleague, or family member who always asks how those prints are made. By the end, you'll understand not just how it works, but why each step matters and how to get better results every time. Let's start with the first step, getting your model. Step 1. Getting the 3D model. Before you can print anything, you need a digital 3D model. Think of it as the blueprint of your part. It's what tells the printer what to create. There are 3 main ways to get one. 1. Design it yourself, using CAD softwares like Fusion 360, Tinkercad, SolidWorks or Blender. Designing your own model gives you full control and it's great for functional parts or custom designs. It does take a bit of learning, but it's a key skill if you want to make unique parts. 2. Download an existing model. If you just want to print something right away, you can find thousands of ready-to-print designs online. Websites like Printables, Thingiverse, MakeWorld or Colts offer everything from phone stands to figurines and tools, often for free. Quick tip. Always check that the model is watertight and optimized for FDM printing to avoid issues later. And 3. 3D scanning. You can also capture real-world objects using a 3D scanner or even your smartphone. Scanning is a great way to reproduce or modify existing objects. But keep in mind that scan meshes usually need some cleanup in CAD software before they're ready to print. Once you have your model, whether it's designed, downloaded or scanned, usually saved as an STL or 3MF file, it's time to move to the next step, slicing. And if you're curious where all this started, how FDM was invented and became the world's most common 3D printing process, check out our 3D Explained episode on the history of FDM and FFF after this one. Step 2. Slicing. This is where the magic of digital preparation happens. A slicer is the software that converts your 3D model into layers and generates the instructions that your printer will follow. Programs like Prusa Slicer, Bamboo Studio, Cura or Orca Slicer are among the most popular. Here's what happens. The slicer cuts your models into hundreds or thousands of thin horizontal layers, and for each one it calculates how the printer should move, how much plastic to extrude and at what speed. That set of instructions is saved as G-code, which is what the printer actually reads. But slicing isn't just a technical step. It's where most of the print's success is decided. A few key things to pay attention to. Orientation. How your model is positioned on the build plate. The right orientation can save time, improve surface quality, and make support removal easier. Layer height. Smaller layers mean higher resolution, but also longer print times. Infill density and pattern. More infill makes parts stronger, but also heavier and slower to print. Support. These temporary structures are used for overhangs and need to be removed later on. Pro tip. If you're new, start with one of your slicer's default profiles. They're optimized for your printer and material. Once you get the hang of it, you can start tweaking things like speed, cooling and wall thickness. Once you're happy with your slice file, save it or send it to your printer and you're ready for step 3. Step 3. Printing. This is the fun part, watching your design come to life layer by layer. FDM or fused deposition modeling works by heating a plastic filament, extruding it through a nozzle and depositing it precisely where needed. Each layer bonds to the one below it, slowly forming your object. Now, even though the printer does most of the work, there are a few things to keep in mind for a smooth print. Bed leveling. Make sure the print bed is level and the first layer sticks well. This is the foundation of every good print. Most modern 3D printers auto-level, so if you notice poor adhesion, rerun that calibration. Clean bed. Residue and oily fingerprints reduce adhesion. Wipe it with isopropyl alcohol or dish soap before starting. Temperature and material choice. Different filaments need different nozzle and bed temperature. PLA, PETG, ABS and others each behave differently. Monitoring, especially on long prints, check occasionally to catch issues early like spaghetti or a jammed extruder. Safety, always print in a well-ventilated area, especially with materials like ABS or ASA which can emit fumes. And remember, patience is key. 3D printing isn't the fastest process in the world, but it's definitely one of the most satisfying to see. On the topic of speed, if you're feeling impatient or need a print done in a time crunch, check out our 3D Explained on speeding up your FDM 3D prints. Once your print is done, it's time for the final stage, post-processing. Step 4. Post-processing. When your print finishes, it's usually not completely ready to use. There's often a bit of cleanup involved, and sometimes finishing touches can make a big difference. The most common post-processing steps are support removal, snip or snap off any supports you added during slicing, surface finishing, you can sand, paint or vapor smooth your prints for a better look, and assembly. Some parts are printed in multiple pieces that you can glue or screw together. If you're printing functional parts, this is also where you can check tolerances and fit, especially for mechanical assemblies. Post-processing is a manual step which consists in tons of techniques from painting to electroplating. This is a step which can make your plastic print a true work of art if you put in the labor. And that's it, the 4 main steps of FDM 3D printing. Getting your model, slicing, printing and post-processing. Each stage has its role, and understanding them is the key to becoming confident with 3D printing. Now that you know the 4 steps of FDM, you can start creating your own parts. And if you want to go deeper, check out our video on the real cost of 3D printing. It's a perfect next step once you've mastered the basics. Or if you want to understand what makes materials like PLA, ABS or high-performance polymers so different, explore our 3D Explained series on filament types and properties. We cover standard, advanced and high-performance materials. Until next time, happy printing!